$26.06 on this card.
Everyone but Brandon, right?
No, I love when they like do that.
All right, so Virginia was asking about question number 3, and that question said x cubed plus 36x squared plus 32x.
I can't find it right now.
Okay. Just take a picture of it and find it or bring it in again.
Oh, okay.
Okay.
Okay, then goodbye again.
Okay. What do you do first?
You take out an x.
Yeah, take out an x. So pull out the GCF. First step, first question for every problem is our GCF. Factor that GCF out. And then it's trinomial, so the next step would be, Sabrina, to see if
See if you can do the AC grouping method, but you can't
because
32 can't equal 36 anyway.
there's no way to take any of the factors of 32 to give you 36. The largest combination would be 1 and 32, which would give us 33. So this one does not factor any further. The only factoring you can do is by pulling out an x. I believe number 14 is another one that's similar to this. Yeah, number 14. So 14, you have 4x squared plus 64. So you can pull out a 4 because it has a GCF. You get x squared plus 16. Why doesn't that one factor? Virginia? Yeah, because it's addition. So this does not equal x plus 4 times x plus 4. Because x plus 4 times x plus 4 makes x squared plus 8x plus 16. And that doesn't have that 8x in it. So must be subtraction in order for you to factor it. The sum and the difference doesn't work either because then that would give you a minus sign. So does not factor any further, pulling out the 4 as far as you can go. All the rest had some type of factoring involved in it. Any questions on the factoring? So I will say that compared to the notes that we did yesterday, this did not have any x to the 4th and a y to the 4th. Yes, there was, like number 9 had the 2 variables, the x and the y. 10 had the 2 variables. But otherwise, this I think was hopefully a pretty straightforward factoring worksheet. On Monday, you'll have a small factoring quiz. There's 7 questions. I think it's 16 points. So make sure you look over the factoring notes. Look over these. We'll do it for a portion of the period. It's only 7 questions, so maybe like 15 minutes. And then we'll be working on solving equations involving rational exponents, involving higher power polynomials. Any questions? So in your packet then, if you'll turn to page 11. We're going to talk about solving equations today. Today's equations will be linear and rational. And then we'll also look at graphing some equations to kind of support our algebraic answers. And those equations will be absolute value and quadratic. So when we're solving equations algebraically, and you're dealing with fractions, what is the easiest way to solve an equation with fractions? And this just has like regular fractions. The fractions, like the x isn't in the denominator. What could you do with the fraction? Jenny, have an idea? You're really close, really close. You want to multiply by something, but not the reciprocal. You're so close. Eris? Right, we want to use the least common denominator so that we can try and get rid of fractions. What is that in this problem? Yeah, 4. Yeah, so we have a 2 and a 4, so the least common denominator would be 4. Instead of keeping the fraction, fractions. Remember, you don't like fractions to begin with. Maybe after last year, you feel a little more comfortable with them, because we did use them a lot. But we're gonna try and get rid of them. And she said the least common denominator was 4. If you take the left side and multiply by 4, and the right side, because whatever you do to the left, you have to do to the right, also multiply by 4. You're keeping the problem equivalent. You can do anything in an equation that you want. Like you could multiply by an x squared, you can multiply by 52, as long as you do the same thing to the left and the right. The reason we want to do that is because when you multiply 4 times 3x over 2, there's 4 times 3x's divided by 2 gives you 6x. No longer is a fraction represented for that first term. By multiplying with the least common denominator, the fraction is gone. Eris, how about 4 times a fourth? It's just 1. I'm going to write that one just so that you can kind of see that we have something there. And then the parentheses is x minus 2. That doesn't get multiplied by the least common denominator because the number in front will affect or change anything that's in the parentheses. So if you've already multiplied by the number in front with the least common denominator, then you're not doing anything with that parentheses. It just stays as x minus 2. Try and think of the parentheses as being like it's excluding the other pieces. So it's separating them from the rest. On the other side, 10 times 4 is 40. So in one step, by taking a least common denominator, distributing it through, we no longer have fractions to worry about. So we're not keeping them, we're actually getting rid of them. So if this number was something else, if it wasn't a 1, then we would distribute it through the parentheses. Because it is a 1, it just keeps it the same. So if we combine the x's, take the 2 to the other side, we get 7x is equal to 42, or x is a positive 6. Any questions with that? I feel like you guys are in the dark. I didn't turn the lights on. It's still dark back there. Those lights definitely helped turning them on. Any questions? Okay, so we're going to use this process to try and solve the next problem, except the next problem now has the variable in the denominator. So this takes it from being a linear equation because the x was in the numerator to being a rational equation because the x is in the denominator. What do you have to do first with one of these fractions, Chelsea?
The fraction on the right, you have to do the AC.
Yeah, so this one on the right needs to be factored. The reason we want to factor it is to make sure we can see all the pieces of the denominator to get that least common denominator. What would that be, Chelsea?
X minus 2 times x.
So then the least common denominator would be,
X minus 2 times x.
right, x minus 2 times x minus 3. So just like we did with the one above, we multiplied by the least common denominator of 4. We're not changing that process. We're just going to multiply by the least common denominator of x minus 2, x plus 3. And again, you can multiply by anything that you want, as long as you do it through the same thing to both sides. So our goal is to get rid of the denominator, not keep it in the fraction. And doing that, you distribute your least common denominator to both parts. Virginia, do you remember what happens when you use the least common denominator in the fractions?
The bottom and at the top cancels out, so it'll just be, that's going to cancel out. Just be the x plus 3, and the other will just be times the x minus 2.
Excellent. So the denominator x minus 2 cancels, and we have just the x plus 3. Essentially what wasn't in the denominator goes to the numerator. The second one, the x plus 3 cancels, and you have an x minus 2. And then on the right side, you have this x minus 2, x plus 3. It cancels because I'm multiplying it by the least common denominator. So the only thing on the right is 4. Again, our goal is to cancel the denominator, get rid of it. You don't want to keep fractions in the problem. You want to eliminate them. That's why we're multiplying both sides by the least common denominator. So we have 1 times x plus 3. That stays as x plus 3. 3 times x, 3 times negative 2 is 3x minus 6. So you're using the other piece, what wasn't in the denominator, that remains in the numerator because the denominator's canceling out. So Kate, if we combine like terms on the left, take a number to the right, what do you end up getting?
4x equals 7.
So x is
7.
7 over 4. When you have a variable in your denominator, what do you have to remember to check with your answer? Or what can't a denominator be with fractions? Chelsea? It can't be a, what do you mean?
Well, you have to check for extraneous solutions.
You do, yes.
Never mind.
Michael?
It can't like add up to be 0, so
Yes. So it can't be 0. So Chelsea, if this was a negative 3,
Yeah.
then plus 3 would make it 0. So you can't, whatever the number is you have for x, it can't make the denominator 0. And that is an extraneous solution, which is just right underneath. So extraneous solution, it doesn't work when you substitute it back into the original equation. In this case, it's because it was making the denominator 0. This is okay. 7/4 isn't going to make my denominator 0. 7/4 minus 2, 7/4 plus 3, 7/4 squared plus 7/4 minus 6. None of that would make the denominator 0. Questions? So see if you can apply that same process to number 2 on the top of the next page. So you're using the least common denominator to eliminate fractions. Don't keep them in the problem. Get rid of that denominator. Nick, what's the least common denominator?
X plus 2. X minus 2.
So x plus 2, x minus 2. So if we have an x minus 2 in this one, Libby, what goes to the top, or what remains in the fraction there?
X plus 2.
And then in the middle one, we have the x minus 2, so
And then X minus 2.
x minus 2, and the last one?
Nothing.
Nothing.
What?
Yep, because it is what it is. It's that exact same common denominator. So on the left, we have x plus 2. On the right, we have 3 times x, 3 times negative 2, and then the minus 6x. So again, it goes from fraction to linear. The denominator eliminates whatever piece isn't in the denominator is what goes into the numerator and becomes what you're multiplying by. So if we combine our like terms, getting an x on one side, a number on the other. 4x equals negative 8. Because over here, this gives us a negative 3x minus 6. So adding the 3x, subtracting the 2, means that x is equal to negative 2. Is that okay? Why not? Yeah, so here if you put a negative 2, you square it and you get 4. Minus 4 is 0. Right next to it, if you put a negative 2 plus 2, that also makes 0. So this doesn't work. What's the solution? There isn't one. There isn't a solution. There's no x value that's going to work. There's not an answer. So if you check it into the denominator and it makes it 0, that's when it's extraneous. So we would say that -2 is extraneous. There isn't another answer that we found, so it's just no solution. Any questions? So we just did, bless you, 3 problems involving fractions, trying to use the least common denominator. Going to kind of go another way here. Look at a different kind of problem. And that would be an absolute value problem. So this one wants us to find x and y intercept. So we're not solving. We're going to see if we can find an x and a y intercept algebraically, and then we'll also try and kind of think about it graphically. So x intercepts. We know it's where the graph crosses the x-axis. Y-intercept, where the graph crosses the y-axis. How do you find an x-intercept?
So y equal to 0.
Yeah, set y equal to 0. So Michael, to get an x-intercept, or y-intercept,
Set x equal to 0.
set x equal to 0. Which one of those do you think would be easier to find if it's already in y equals 4? Chelsea?
Oh, the y-intercept.
Yeah, the y-intercept. You already have y by itself. Michael just said you make x 0. So that means you just take the equation, make x 0, and evaluate. Because the y is already by itself. You don't need to move anything. So Chelsea, that means y is just -3. How do you write a y-intercept? What does it look like?
0,
Yeah, 0, -3. It's an ordered pair because it's a point on your graph. The x is 0 when y is -3. Alright, so then looking at the y equaling 0, take our equation, y is now 0 to get that x-intercept. We have the absolute value of x plus 1, and then -4. Now we have to get x by itself. What do you do to get x by itself first? Harris? Yeah, get that 4 to the other side. You always want to try and get x by itself, get anything else that isn't x to the other side. And now x is inside these bars. These are absolute value bars. Do you remember what to do?
Have it equal 4 and then -4.
Perfect. Yeah, so absolute value means a distance a number is from 0. But remember, a number line, you can have the same distance -4 to 0 as you can from +4 to 0. So to get rid of the bars, you separate, make 2 equations. X plus 1 is equal to +4, x plus 1 is equal to -4. That accounts for the fact that 0 is in the middle of -4 and +4. They're the same distance to get the 0. And then when you solve, you get a +3 and a -5. So the ordered pair 3, 0 and -5, 0. So a y-intercept, plug in 0 for x, really easy to solve for.
It's 5 and
Say it again.
Oh wait, never mind.
Any other questions? So that's the algebra. We're going to just verify graphically, making sure that the algebra connected with the graph. So if you go back up to the graph, or the equation, y equals the absolute value of x plus 1 minus 4. What kind of graph will it look like if it's absolute value? Chelsea? Yeah, this should be a V. So absolute value makes a V. The reason we have a -5 and a +3 is because of it having the 2 sides. So if it has a V, Chelsea, where's the vertex?
-1, -1.
Remember H and K from Wednesday, those basic graphs. So -1, -4 is where you start, over 1, down 4. And then apply the absolute value. So you don't need to do anything else with the equation. You just have to remember you're taking the absolute value of x. So going right 1, the absolute value of 1 is 1. Right 2, the absolute value of 2 is 2, and you can just kind of follow that same pattern, absolute value of 3, and so on. And then moving to the left, -1, absolute value is +1, -2, absolute value is +2, and so on. So just checking your intercepts. The x-intercept, here's one at 3, 0. The x-intercept, the second one at -5, 0. Those are the exact same ones we found algebraically. And then the y-intercept is down here at -3, 0. How about -0, -3? There we go. 0, -3. So the graph kind of just confirms the algebra that we did. Questions? So there is one more problem on the other side. And instead of finding x and y intercepts, this says find the points of intersection, which is essentially solving for a system of equations. So we want to find out where they cross, where are they meeting, and it says points, pluralized. So if you look at the two equations you're given, x minus y equals -4, x squared minus y equals -2. Because of that second equation, we're going to have two solutions and not just one. So graphing is one way you can solve for a system of equations. What were the other two ways that we talked about? Chelsea?
Elimination and substitution.
Right, elimination and substitution. Either one of those work. It's your total, like, whatever personal preference, whatever you see when you look at the problem. Either one works. Alice, how are you going to try and solve it?
Substitution.
Okay, so if you're substituting, which one of these are you going to get into?
The top one.
Okay, so what are you doing with the top one?
So I'm bringing the x to the other side. And then because they're all negative, you can make it so the y is positive and so on.
Excellent. Good explanation. So she took the first equation, x to the other side, as she said, they're all negative, so that becomes all positive. And substitution means replace. So you're taking the x plus 4 and replacing it in for y. So Alice, what does that look like when you replace it in for y?
So the x squared minus x minus 4 equals -2.
Nice job. There's a minus sign here. So if you're replacing it in for y, you're taking the x plus 4 and making it negative because it says minus y. So this is positive y. That means minus y needs to be the negative x and then the minus 4. And then setting this equal to 0 gives us x squared minus x minus 2. So really quickly here, Alice, what do you have to do with this?
Well, so it will be x minus 2 and x plus 1.
So you gotta factor it. Not just a line, it has an x squared. So it gets factored and then it has two x's. One's a positive 2, the other one is a negative 1. That means I have to get two y's to correspond with both of those x's. So after you factor it and you get your x solutions, you already have y here by itself. Y equals x plus 4. So if x is 2, plug it in. 2 plus 4 makes 6. So you're taking the x, the one solution, plugging that into your y equals equation. If x is -1, -1 plus 4 is 3. That would be our second solution. We're not going to have time to graph it because of the fire drill. But you would graph the line, you would graph the parabola. They would intersect at both of those points as well. Anyone have questions? Your homework is on page 7 of the homework packet, so back in the homework packet. I will say that this is probably the first assignment that's a little more involved. So you have the basic graphing assignment where you're just graphing. Yesterday it was just factoring. This one definitely is a little more involved because you're actually back into the solving equations. A couple of them are a little interesting. So Monday, again, factoring quiz. And then we will look at some of the equations that we'll be solving for the next section. Anyone have questions?